Hey there, folks. Welcome back to Advent of Code 2023, where we're being dumb and using Visual Basic 1. This is day number 2. We've got our puzzle here. Let's see if we can fire this off. Last video was way too long. So here we are. We're launched into the atmosphere. The apex of your trajectory just barely reaches the surface of a large floating island in the sky. You gently land on a fluffy pile of leaves. Okay, it's cold and blah. An elf comes. He explains that when you come to Snowland, he apologizes for the lack of snow. He's going to be happy, and you got to walk somewhere. Okay, so we're walking, and we're walking. Now he wants to play a game with us. I think we're forced to play a game. As you walk, the elf shows you a small bag and some cubes. Okay, we got red, green, or blue cubes. Each time you play this game, he will hide a secret number of cubes in each color in the bag, and your goal is to figure out information about the number of cubes. Okay, well, that sounds fantastic. To get information, once a bag has been loaded with cubes, the elf will reach into the bag, grab a handful of random cubes and show them to you, and then put them back in the bag. He'll do this a few times per game. You play several games and record information. Okay, so we're just in game 1. Okay, so this is a semicolon separated list of subsets of cubes. So, okay, so for game 1, he pulls out 3 blue and 4 red. Oh, and he puts them back in the bag. So then he puts them back, and then he pulls out 1 red, 2 green, and 6 blue. Then he pulls out 2 green. Okay. Fantastic. In game 1, 3 sets of cubes. Yeah, we figured that out. The elf would first like to know which games would have been possible if the bag contained only 12 cubes, 13 green cubes, 12 red, 13 green, and 14 blue cubes. Okay, so 3 is impossible because he pulls out 20 red, but there are only 12 red cubes. Okay. Similarly, game 4 would have also been impossible, I guess because of the 15 blue cubes at once, and he's only got 14 blue cubes. Okay. If you add up the IDs of the games that would have been possible, you get 8. So 1, 2, and 5 are possible. See, now because we've got a two puzzles per day, and this thing is, puzzle 2 builds on puzzle 1, I have no idea because I haven't solved this first one yet, but I am going to assume that once we solve this, he's going to do it again, and he's no longer going to put these things back in the bag. That's my guess. I have no idea, but I think that's what's coming. So when we design our solution, let's design it with that in mind, because I'm pretty sure that's what's going to happen. Okay, so we have to read in this list of games. We have to determine which ones were possible, and then add up the possible ones, and we're off to the races. Okay, let's do this. Sounds like a super fun game. This is our form from last time. This says day 1, but we should maybe call this day 2. And everything is the same as last time. Here's our calculate button with all the gloriousness of what it is. I made a copy because I thought we'd sort of be building off of these things, but maybe not. Maybe not. So anyway, what are we doing? We have to bring in input. So I've saved all of these inputs to a folder. And so I'm just going to change this text to be day 2. Test input A, because there's going to be 2 of them. We'll probably only get through 1 in this video. Okay, and then we're going to calculate. I kept the test bar and button just for kicks. We might need that. And we don't need this we don't need any of this calculate stuff. Now we got other stuff in here. From last time, we're carrying over this stuff. But these are well hidden in the interface. I don't even need to care about it. So I'm just going to leave them just for kicks. Okay, so we're going to have to start off by getting the file name. So file name equals, it's the txt file name dot text. Okay, and then we're going to open the file name for input as number one. Whoops, yep, number one. And we're going to close number one, because you always have to return the resources to the operating system. Okay, so we've done that. Now we need to read in these things. And this is my test file. I made it here, test input A. So we've got we've got 5 games, and we have to read in until we hit a semicolon. Now, are they all the same? Like, so in this first game, the first time he pulls it out, it went blue, red, one green, blue. Okay, so blue came after red in this list, but it came before red. So we have no idea. It's just a certain number of... We don't have any other colors. We just have red, green, and blue. Okay. Okay, so let's do that. So we are going to say for line equals 1 to 5. All right, we'll call it game. Why not? That's for game equals 1 to 5. Next game. Okay. Line equals input number 1. We're going to read in from the file the first line, and that is going to be, oh, wait a second. No, I forgot. I forgot how to use the input statement, of course. That's in line string. Actually, you know what? This is, no. Line. Next line. Because it's the, shut up. Oh, I think line's a keyword. Is line a keyword? Of course line is a keyword. This is fascinating. I didn't know you could draw primitives in Visual Basic. Huh. Okay, awesome. Had I known that when I was in high school, maybe I would have done something like that. So line doesn't work. Of course not. My word. Okay, for I. We're going to go back to I. Stupid variable names. Okay, we're going to do game string. So game string is going to be the text of our game. Now, the thing that I'm concerned about is that we are going to equals game string. And then we're just going to, and I'm just going to, no, let's just exit for. I know that's stupid. That's stupid. What I'm concerned about is these semicolons and these commas, which like destroy QBasic's input function. So let's just calculate. Yeah, see, path not found. What? Day underscore. Oh. Okay. Oh my word. And I guess my path is wrong. 0. Is it 0? It's 0, right? Excellent. Okay, so actually what I'm going to do, because I want to really see how this reads in. So I think what it's reading in is by default, it reads in until a comma or an end of line. And the thing is, can I say, no, don't read in from a, like don't stop at a comma. If you hit a comma, keep going. So let's find out this input statement. Input. Data items in a file must appear in the same order, blah, blah, blah. Ah. Right, you can, oh, interesting. So if there's multiple things separated by commas, you can read it in. Oh, that's interesting. The argument variable list is a comma-delimited list of variables that are assigned values read from the file. I feel like there was something else here. Is that all I get? Leading spaces are ignored. With numeric variables, the first character encountered that is not a space is assumed to be the start of a number. The number terminates when a space, comma, or end of line is encountered. Blank lines are input as 0. With string variables, the first character encountered that is not a space is assumed to be the start of the string. There we go. The string terminates when a comma or the end of a line is encountered. Blank lines are input as null strings. If the end of file is reached when a numeric or string item is being input, the input is terminated. Yeah, so we read the line. So our lines include semicolons and commas, and I just want it all. So what I'm going to... Interesting. Okay, let's not do this. Let's tack on. I'm just curious how this works. Let's just concatenate it and we'll see what we get. So this is 1 to 5. We're going to do it 5 times. Nope, path not found. Oh my goodness. Oh my word. Okay, let's change that. This is frustrating as all. Okay, there we go. Run, start. Okay, calculate. This is 5 things. Interesting. So, like, we got them all. So that was the first one it read. Then it read this. Then the 2 green, right? And then the 6 blue, 2 green. Okay. Okay. So if we do 4, oh shoot, but no, this isn't going to work because we have a variable number of things. We can't just input. Okay, let's okay, so we need some kind of an array. Let's come on, we're going to have I mean, could we just do, I suppose we could do a struct, or a type. Basic, they're called types. We could do a type. So if we had a type, let's say pick. Invalid outside global module. Oh my word. Okay. We got to shove this in here. So we're going to make a new type. Now basic is not object oriented. You can't do classes or anything, but we can make types which are basically structs in C. So we could say pick invalid outside global module. This is my general declarations. What are you talking about? Oh, do I have to? Goodness me. Used in a global module. Where's my global module? A user-defined type must be declared in a type declaration before it can blah, 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 blah. You can declare a variable, blah, blah. Use dim, global, or static to declare. What? So I can go global type pick? What? Oh, do I have to like make a module? That's above my pay grade. Module, for crying out loud. Okay, let's do the new module. Let's see what that's all about. Type pick. Invalid outside the global module. So edit. So where's the global module? How do you do a global module? Is it... What? Okay, I guess how to. Global module. Maybe I should like global module. Hey, here it is. Here it is. Talk to me. Entering declaration. Blah, 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 blah. A global module is a separate code structure that is automatically created for each project contains. Well, blah, blah, blah. For details on scoping declaration. So where is the global module? Adding, removing, creating a general procedure. What the heck is going on? Oh, it's right freaking there. Holy crap. It's right. Okay. Type pick. There we go. And type. We can have properties in here. I'm going to have red as integer. I'm going to have green as integer and blue as integer. There we go. And that's it. Now, is this going to run? Did I? No. Yeah. Okay. Let's get rid of you. Come on, run. Run the freaking thing. Okay. I'm calm. I can do this. Okay. We have our type. Stupid type. I want to delete this. Can I delete this? No, of course not. That's there forever. Okay, so we're inputting. These are our lines. So we're going to input game. We are never going to. Okay, let's go back to our structure of our. Every time there's a comma, we're going to end the input because that's just... Oh, and we can't not. So there we go. That's fun. You know what I could... Am I allowed to just replace these things? Is that cheating? Is that cheating? Can I just... Nah, that's cheating. That's not in the spirit of this. Okay. I was just thinking I could just in a text editor replace all the semicolons. No, but I need to know the semicolons. Whatever. Okay, we're going to input something here. And it's either going to be like game1 : space 3 blue, or it's just going to be the like one of the colors. So what I need to read in, I need to continuously read in until I hit another game. And once I've hit another game, I can take all the previous ones and sort of like sort them. Oh, for crying out loud. Is there no way? Is there a read statement? Am I doing this wrong? I know there's a... This just seems so limited, this input. Oh, this is the one that's read from the file. Input number. The end of file is reached when a numeric string input is terminated. All right, well, we're gonna have some chunks. I don't know how else to do this. Redim chunks. Give me 1,000 chunks as string, and then we're gonna have a current chunk. Num chunks equals 0. This is that, although we should probably make it a long. Who knows how much our test input. So the idea is I'm going to read these things in chunks, because whatever. And then I'm going to have to replay all the chunks and figure things out. So, yeah, I guess 1,000. I don't... If I do 1,000 and I keep trying to read past the end of file. See, how do I detect the end of a freaking file? Why do I get that error? Why doesn't the help F1 go to that? Maybe because there's two things called input. I've been staring at this stupid help file for what probably amounts to hours now. End of file. There's got to be something with end of file. The end of file. Whoa. Returns a value during file input that indicates whether or not the end of file has been reached. Use the EOF function with sequential files to test for the end of a file. So this example, okay. This looks like crap. This is awful. Do while not EOF. Oh my word. We're going to do a do while. None of these for loops for us anymore. Okay, so we're going to say do while EOF1 is not equal. What is it? Not equal. What is it? While not end of file 1. Ugh. What is that? What is the while not end of file? Does the not? Oh, I guess EOF returns -1 if it's the end of file, and that amounts to a false. Okay, whatever. I don't need another check. Okay, we're going to have a do loop, and then we're going to say num chunks equals, we're going to increase num chunks because I can do that. Num chunks +1. So yes. So we started at 0. Every time we're going to read in a chunk, it's going to be yeah, then we're just going to store it. Chunks of num chunks, say that 3 times fast, equals, oh no, we're going to read this in, right? Input number 1 chunks. Can I do that? And then if I go down here, instead of this crap, let's just output the number of chunks that we've read in this stupid file. What? What are you talking about? Oh, because I don't know what I'm doing. That's why. That percent needs to be an ampersand. Gotcha. Okay. Run. What are you... Okay. Okay. There we go. So I used 26 chunks for that. Okay. That works. Let's end that. Now, how do we turn a series of chunks into what we want? So we have chunks, and now we're going to say we're going to have an array here, and this is going to be called games. Games, I'm going to guess there's 1,000 games. Oh, actually, a game is going to be a series of picks, right? Oh, for crying out loud. Actually, okay, let's go back to this. Pick is stupid. This is now a game. Red isn't an integer though. It's like a variable amount. Feature unavailable. What? What are you talking about? The feature is unavailable? Not just, you're not allowed to do that? Like, oh no, we know about this. We're just not going to let you do it. Okay, I guess they're picks again. All right, so we got all of our chunks. Okay, I need to construct a game here. So for I equals 1 to num chunks, this next I. Okay, we're gonna have a current game equals 1 because we're reading in. We're gonna look at these games. Actually, current game is 0. We will start on game 1. What is happening? Okay, we will start at 0, but we're going to look at these chunks and only increase the current game if we get to a game chunk. So if the mid string, so mid string of chunks I, starting at the first place, and what is that, 4? 4. So if that equals game, so this is a chunk that's starting a new game. What are you complaining of? Okay, yeah, you're right. Okay, then current game, I should put a % sign on this, or else it's a single floating point decimal equals current game plus 1. Okay, we found a new game. Hurrah! Okay. We also need the name. Oh man, we need to keep track of which game it is. Okay. And if. Okay, so if the mid of the chunks. is game. Then we found a new game, and the I guess we need current game index. How long can you have these file names or these variable names? Current game index. Because I want the actual. So let's go. Redem games 1000 games as I'm guessing they're just going to be integers. Whoops. My idea is that this is going to be some kind of a bit flag for if the game is possible or not. Picks. How do you do that? How do you do that? If a game is a series of picks, games as picks, does that work? No, I would need it to be an actual multi-dimensional array. How many picks am I going to need? 100 picks? 100 picks maximum per game? Okay, let's try that. Just want to make sure. Oh, we've got over half an hour already. Okay, so we got this going on. Stupid. Then wait a second. The current game index is the stinking game. We're fine there. We don't even care. Okay, else if, what are my other options here? It's going to, I should have saved that. Right, because this is going to go game, it's going to go all the way to the 3 blue. So I want to take off everything, stinking semicolon. Is there a... Oh. It's okay. It's okay. I got this. You know what? I think what we're going to do is we're going to do this a silly, stupid way. Oh, but come on. You've got to be kidding me. There's not even a replace in this thing. I'm thinking, you know what? Like, enough is enough. These... If I stare at this long enough, maybe it'll come out to me. Why does it stop at a comma? Is there no other way to do this? Don't stop at a comma. Okay, let's do some searching here. This isn't going anywhere. I want to read in some data. Did I refuse? Absolutely refuse to believe that this is not possible. Now, one thing I did see is that this input string function why didn't I see this 100 years ago? Returns a string of characters read from a freaking file. The word freaking is not in there, of course. The number of characters to read from the file. The number that was used. So if the file is open for random access, which we're not opening it for random access, if the record length is not set, unlike input pound, input string returns all characters it reads, including carriage returns, line feeds, and leading spaces. So this example uses the input function to read one character at a time. Get a file name. What file do you want to? Okay, blah, 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 blah. Open the file name. Keep inputting one character. If it's not a line feed, add the stinking, oh my word. That's it? Okay, I can't do this anymore, but we're going to pick this up next time and use this stinking input string function that I missed 100 years ago. Okay, thanks for joining me. We'll see you next time.